for session number 5. Bit of noise coming from the upstairs chavs, bear with me. Should be just a little bit of time before that goes away and I'm ready to just sort of bang out. Literally just get started on what I was going to do. Where we left off last time, we are just kicking off with 1 parts 3, so project 1, MapReduce, parts 3, the scheduler. Gonna go straight back into that, no need to put in any more time preparing, because literally all the time that was necessary was put in yesterday. So it should be good. Let's get started. DS folder, scrap, schedule, right, so this is it. So this is my summary of what needs to be done, and all we need to do is have a look at that and kick it, right? Kick it old school, rush through it. Well, hopefully it won't be too hard. I'll have to implement a bit of concurrency, which, you know, should take a bit of thinking about, but hopefully not that much thinking about. So it gets called by master, calls it twice per job, map phase, once for the map phase and once for the reduce phase. Let's just load up schedule. You can see from the signature, we looked at the signature at the end of yesterday. Signature is quite important. So it gets per job. So, you know, the job name is going to identify a job. That's the first argument. The phase, which is map or reduce for that job. And then, yeah, we pass in register chan, which is something that's always in the background telling us where our which workers we have. The workers identify themselves by posting their addresses to register chan, and this just picks them up as they're coming in. And then we have these parameters map files, which is the list of input files, and nReduce, which is the number of output files, effectively. Another way of saying that is the number of reduce tasks, because of course the length of map files is the number of map tasks. So nmap is the number of map tasks by definition, is the length of map files. And nReduce, we determine ourselves, is going to be the number of output files. Just going to quickly check that everything is in order here. Still have the first time streamer paranoia, although this is now stream number 5. Well, it's been going well, to be honest. I have to say, on the streaming side I've had very few problems. Very few things to have to deal with or even think about, really. It's all just sort of been ticking. So yeah, this is the little bit of boilerplate at the top that sets the variables to what we think they should be. We went through that yesterday as well. Pretty simple. N tasks is the number of nmap or nReduce, and nother is the opposite one, nReduce or nmap respectively. Depending on what the phase is, whether it's map or reduce, and that's how they get set here. So that's pretty self-explanatory. Well, and we explained it yesterday anyway. And here we have just a couple of print statements to tell us what's going on. Your code here. So let's get to it. The purpose of schedule is it hands out tasks. Gives each worker a sequence of tasks one at a time, returns when all tasks have completed. Find workers via register chan, which yields the string of RPC addresses. This is just a clarifying detail that is really explaining the obvious, that the workers are coming in independently of schedule. That's the way it should be. And yeah, then it sends these tasks, execute task, and it'll be handling workers as well later. So Okay, let's see if we can sketch that out in the code. Then we're using comments. That's the skeleton, the first step. So I mean, beginning here, obviously this just sets the parameters. That's fine, and this says okay, schedule, n tasks, phase tasks. So n phase tasks, n map tasks, or n reduce tasks is what that is. And then other is the opposite one. So I/O, what it means is the other task. I mean, it would make more sense to say to have like, you know, this many tasks, and input output's a bit ambiguous, but it means what we think it means, because like we said, nmap and nReduce, those two parameters are the numbers of input files and output files. That's what they equal. And the interface where map passes to reduce is what this means. You know, input and output along that interface. So input into the reduce task, output from the map task. Yeah, so this is literally just the beginning. It says when schedule is initially called, it says schedule, you know, be a bit clearer if it said schedule start, and then this many map tasks or reduce tasks. I'm going to put in the word start just to make it a bit clearer. This is schedule finish. You know, that phase is done, as in that phase has been not only sent out to be done, but it's actually finished. That phase has to have finished, so schedule watches it. Schedule blocks while awaiting for it to finish. All end tasks have to be scheduled on workers. Once all tasks have completed successfully, schedule should continue. As in, it says return, but what we mean is continue onto this line, because it returns immediately after that. And then we have a your code here block. So yeah, let's make some space. Fucking linter. Yeah, okay, so gonna just clear this up a bit. I'm gonna paste this here, get it out of the way, and then the your codes here thing, and this will be the code. Okay, let's see if we can sketch the function. So the first thing I have on my mind is to await at the end all of the tasks to finish. So we're going to be using sync.waitGroup as it said in the hint earlier. It's not written down here, I don't think. Did I forget to write it down or something? Probably. But yeah, that's maybe I forgot to save the file. This doesn't look completely complete. But yeah, it's supposed to await everything finishing. So the last bit is just await all tasks to be complete. We want to have a channel representing every task, I think. A channel for each task starts coroutine. Let's write go routine to keep it idiomatic. Because it has to pass them out to the workers one at a, well, each worker receives a sequence of tasks one at a time, and the scheduler then just chucks them at the workers. I don't know a good way of choosing which worker should receive which task. Because if none of them fail, then you can. If there are no failures, then it doesn't matter. You can just go through. Well, increment by one. I guess that's the naive strategy. We just go to. you know, we have like K workers. Well, it doesn't matter. We have a bunch of workers. We always just, and they're in an order from like labeled from 0 to K minus 1 or whatever. And then we just go to the next one each time we need to try a task out, no matter if it passes or fails the previous one, and schedule things that way. That way it's not going to. Some tasks may get unnecessarily backlogged by that if they keep getting assigned to the same worker. That doesn't work. But at the same time, that seems not clear. Like, it's not clear that that's a problem. I just think it might be a problem. And so it's just do the simple thing. I think in that case, send them out to the workers. I would say there needs to be a go routine that tracks all of the workers that are available. I don't know what a good structure is here. Maybe I'm gonna have to start drawing on paper what I think, or, you know, maybe I can just use a notepad document just to make it easier to stream. So a new notepad document. Workers coming in to register Chan, you know, with their addresses, and this needs to be handing out shit. Maybe I don't know if mutex is the best way to do this. I'm thinking, okay, so this is idea number 1 for how to implement this kind of thing. We have a list of workers, available workers list. So every time something arrives in register Chan, it adds it to available workers, and we're just constantly, for each new task, we are just iterating across available workers. You know, it does say in the bit of a cold still, it does say in the yeah, it's actually tickling my nose, so I'm just going to blow it briefly. Levels of oxygen. Oh fuck. Air pressure in my ears is messed up. Yeah, levels of oxygen are just depleting solidly in London the past few days. Like, the humidity is just so bad, and now it's all cloudy and shit as well, so tough day to be alive, to be honest. Yeah, as it says here, you know, schedules should use all workers, including ones that appear after it starts. So some of them may appear after it begins. Do we want schedule to immediately, as soon as it knows about a task, to send it out, loop across all the tasks and send them all out immediately, or would it make sense to stagger the loop slightly, sleep the loop a bit, just so that if a new worker turns up in the meantime, it can take advantage of it? Because again, it doesn't seem like there should be a reason for that, to do that it's actually going to give an advantage, like a proper benefit. It's not clear, but I mean, possibly. I don't know. So we're saying, yeah, we're saying here have a go routine for every task. We're going to need some sort of a data structure to keep track of which tasks have executed as well. I think that would be reasonable, even though in the first instance every task will have executed, because we're not testing worker failures. So I'm thinking, do I do the unit testing mentality and just make it work for this and not try to make it work for the next thing in advance? Or do I have a bit of foresight? It's a bit of a doctrine, a dogma, the way people do unit testing in companies. I feel like they feel better about themselves if they go, oh, we're going to just implement a function that returns 0 just to make it work for like the 0 case, and then we're going to improve that. It's complete dogma, it's just unnecessary to do that. Maybe I'm just getting too deep about a single example from an interview, which is a sort of supposed to be an educational example anyway, so not a real thing. Yeah, this is a bit of a jump off the deep end compared to the previous section. But this is the thing, so sync a wait group, that's going to be waiting, when we wait for all the tasks to be complete, that's what we want to do. We want to wait for every task to complete, rather than every worker to have done whatever. So I think having a channel per task, that's what motivated me to say that. I think that's still reasonable, because the other thing is, like, you have a dictionary of finished tasks, and it has to keep scanning that, which is wasteful of resources. Or of course it can just count in a done channel how many like we could instead of using sync await group here, I think we could make a channel in which every task number is sent, and then when all the tasks have been received, like, it just iterates and counts up to the number of tasks, and then when they've all dropped the function continues, returns, finishes. Could do that. Don't know. Channel for each task is okay though, because it means every task is being handled at the same time. I still think I'm going to do that. It's going to be, each one is going to be running in its own coroutine. Each of these channels, and I think you can link the channel up so that it communicates with sorry, I got distracted by the rustling in the corridor. I think it's just my mum likes to root around in the trash for some reason. Quite often notice that. Let's not get too distracted, because I do want to, be a bit more productive in this session. The last session was all talk. Now, one sec, sorry, I'm getting quite distracted. Yeah, sorry about that. Definitely, I just can't think when I hear that kind of rustling outside. It's just extremely distracting. Maybe I should just learn to ride that. Yeah, she just left the house. It takes her like 10 minutes to get out the door. Okay, we can continue now. Do I want to? I mean, okay, yeah, I started sketching it out on paper here. Workers coming in to register Chan. Shall I just, I think the best way to do it is going to be to just bash out a solution and then critique what is good and what's bad about it before implementing it. So let's just try to sketch something that works. That thunder again, mate, not again. Oh no, not again. Gotta get those potholes in your lawn. Yeah, workers constantly coming in to register Chan. So I'm gonna use go as a kind of keyword. Well, I mean, simulating the Go language itself, where Go is used to start a coroutine. I'm going to use Go to identify coroutines that I'm thinking of doing. So let's say we have one called register, which picks up, iterates over register Chan. What we mean by that is it's just waiting for stuff to come, and thing about register Chan, I don't know how it works exactly, but do we get a message every time? I don't think we do. Like every time a task completes, the worker returns a message. Where does that information go? That's what I'm trying to figure out. I guess this is the thing. We don't, in this part of the task, we don't receive information back from workers at all. You know, so I'm thinking maybe I should have a brief look at task 4, which is mercifully short in terms of the description on the website, and see if I can like just clock what the worker does. Does it return something? Do I just forget about the worker's return message? I guess let's keep it simple. Let's not do that. Again, for the purpose of this test, I guess we can ignore everything that the worker says and just keep sending stuff to the worker. What that means is that we really can't do that. We have to append to available workers. As in, we can't just keep listening to register Chan for a message every time the worker can do a new task. I don't think that's what's supposed to happen. It's not. We should definitely have a switch statement for distributing the tasks. A select statement. Okay, let's just write this out. This is a Golang province. A Go feature that allows you to pick the next available channel, as it were. The next available code block. So to motivate what I'm going to do, have a quick look at the select block, and so that using that, I'll show you guys what I'm thinking of using it for. So it's in the concurrency section. We have select. it lets a go routine wait on multiple communication operations. So we want a routine to, well actually this is a slightly misleading statement. This is really what I want sync awaits to do. But the point is, select is kind of like a dual to that. So sync wait group, we're going to use that to wait for everything to finish and collect that and then continue. Whereas select, we are just in time. As soon as anything is available, we send something to it. So we're trying to send to like 10 channels at the same time. We're trying to send to 10 channels at the same time, and what this does is it keeps looping. So it's an infinite loop of selects that continually sends stuff until to the first available channel. Better example is here. Take a look at this. It sends it, it sends in a tick as soon as the tick channel is available, which the tick channel is made available every 100 milliseconds. It actually receives from the tick channel, so I should be saying the tick channel sends something every 100 milliseconds, and the boom channel sends a single message after 500 milliseconds. And so this waits for those, constantly waiting, and then as soon as they drop, it runs that case. It runs the first available case. So that's what I'm going to use. That's what I need to use, I think, to do workers. And the thing is, I think that means there should be a channel for each worker rather than a channel for each task. So maybe sync wait group is not what we want to use at all, necessarily. Something along these lines. Select. So again, there's going to be a loop. It doesn't necessarily need to be infinite though. The loop can literally just be. So this is some actual code that I'm typing now. The loop can literally be. We have to distribute n reduced tasks. Sorry, n map, or yeah, depending on which phase we're in. But we have a variable to represent how many tasks we have. It's called n tasks. Okay, do you know what? I'm going to type in the code here to make it to have something that does something up in the code. So we iterate n task times no failures. We're assuming no failures, so we're keeping the code relatively simple. So here's our iterator variable. I equals 0, I less than n tasks, spelt wrong because of camel case convention, I++. And that is the amount of time we're going to run a select block. And don't forget, select waits until one of the cases is available. Well, the thing about this select is that we want to be we don't want to hard code the number of cases. We want the number of cases to depend on the channel, but that's easy, I think. No, you can't do that in. Let's have a look if we can do that. So do a select block with an arbitrary number of cases. Variable number of cases. We'll see if this gives me anything. How to listen to n channels. This is basically it. Do shit. Yep, so this is an endless loop of 2. How do we do an endless loop of n? There is a select function in another package. Okay, this seems to be the accepted answer. Described by the list of cases, like the goSelect statement, it blocks until at least one of the cases can proceed, makes a uniform pseudo-random choice. That means, yeah, this means that we get away from problems of which channel and load balancing. If it's pseudo-random, that should be okay. I have a couple of messages. So different from my distributed class server and client communication. First TCP, UDP, then Java. Yeah, a pile of stuff in the comment here that I have absolutely no idea about. Let me just dig up the comment. So this course is, if you read this, I mean, this course is pretty modern. I think that's the idea that I got when I looked through the coursework. It's entirely like sort of modern distributed systems frameworks like MapReduce, Raft, stuff that was invented recently, and so I guess it is quite a different comment. Actually, what I would say is you should take a look at the old versions of the course. So take a look at what the course looked like in like 2004. It's just completely different. Does this even have? Yeah, it has labs. It's like I think this is actually quite similar to what you're saying here. Like even though I'm not familiar really with any of this stuff, web proxy, simple concurrent TCP, and some file server stuff. Which to me seems a bit more like the old school. Do concurrency using threading and whatever, that stuff. Which I mean, I should probably learn at some point, but I decided to go for the modern shit instead. But yeah, thanks for the comment. Let's jump back. So I'm out here trying to figure out how to do a select statement on an arbitrary number of cases. Let's have a look. Returns the index of the chosen case. If that case was a receive operation, the value received as well. And a boolean, depending on if it's a send as opposed to a zero value because the channel is closed. I mean, it seems like it does what we want it to do. I always have that skepticism about using a package like some other package. That's something that seems like it should just be hard-coded in the language. Do I do this? Let's have a look at the other answers. Wrap each channel in a Go routine that forwards messages to a shared aggregate channel. The idioms are coming out. My unfamiliarity with Go is going to show up when I try to understand what this is saying. We have lightning again, by the way. Fucking London. I said to my friend that I would go out and walk to his house. I don't think I'm going to do that. RIP. Press F for failed plan with friend. Yeah, okay. Wrapping each channel in a Go routine that forwards messages to a shared aggregate channel. So we have the aggregate channel. We have a range of channels which send messages to the aggregate, and then we select things coming in from the aggregate and do a standard switch case. Yeah, actually that makes a lot of sense. That makes perfect sense if you think about it. I mean, I say that like to the viewer, it would have probably made as much sense as 1 minute ago as it does now. But when you have that click, this idea, I like this idea. It's like well, I mean, I'm not sure why select is necessary at all here. And it says, okay, it outperforms using the reflect package, which is interesting. So I might actually go with this solution then. But yeah, what this is saying is you have a channel that literally registers which channel is ready to execute out of the n channels that we're trying to select over. It registers which one is ready and then just does that one, executes it. And so you have what I would say is an infinite loop reading over the aggregate channel. I would write that as range over the aggregate channel and go, rather than this. I'm not sure why it's written that way. And so it just keeps bringing in the next channel that's ready to execute, and then every time it can pick up one of those, it just runs the execution. Yeah, sorry for not being that clear about abstractly what this is, but I'm a firm believer in using concrete examples to explain exactly what you're thinking about. Okay, so let's not actually write up this code, then let's stick to the blueprints, the pseudocode here. So I'm going to write what I want it to do, even though I'm not going to implement this using select, because select is idiomatic in Go. I'm still kind of going to write it that way in the pseudocode. I'm going to say like select, well, we have n tasks. Let's just write that down. N tasks, that many tasks that need to be sent out to something. So range over n tasks, which is to say, because this is just an integer, it just means loop that many times. Select free worker, then workers be wokla. Select free worker. So like what I was saying about the aggregate channel, is that channel can tell us which worker is free by, it doesn't even, we don't know which work, for part 3 I don't think we're going to know whether the workers are free or not. We just select a worker. I'm just going to write that actually. Select a worker, any worker, don't care which one. Oh yeah, no wait, we do know, that doesn't make sense, sorry. I'm getting confused. What's this? Oh, scrap, yeah, never mind. I'll just keep it unsaved. Live the risky life. Yeah, because even if the workers are always going to succeed, they nonetheless should block and exit when they've done a task, so they can then take on the next task. That's why we should be selecting a free worker. Channel per worker, select via aggregate channel. So this is just implementing the suggestion from Stack Exchange. Shout out to user 6169. That's an edit, isn't it? Tim Allclair. Tim Allclair is the one. Why is this being edited by a random moderator? Has the name you? Is it even a moderator? I don't know how Stack Overflow works, to be honest. But yeah, what's your name? Tim Allclair. Shout out to you. Select via aggregate channel. Yeah, keep doing that. And what channels are available? This is the thing. Sorry, which workers are available? That's going to be available workers. That's going to be the number of channels that are in existence in the first place. So that's dynamic, unfortunately. Is it? Yeah, but the aggregate channel is by nature dynamic, because anything can send into the aggregate channel, which is sick, because it means we don't even need to store available workers, do we? God, I just got excited. Hang on. Yeah, sorry. When I get too excited, I need to blow my nose. Lightning outside. One moment, please. Just want to pick up the latent thunder rumble there that happened while I was blowing my nose. It's still going, like, so much thunder. Yeah, yes, boss. I had an idea. Yeah, my idea here is, if we have the aggregate channel, the additional benefits of that other than what we wrote it down there to, what the initial problem it was supposed to solve, is that it's flexible in the sense that anytime a new worker comes in, it can just register on the aggregate channel. The aggregate channel is effectively what the aggregate channel is, conceptually, is a channel registering free workers, but not just once per worker, like every time a worker is free. So I'm gonna use the old, like, I don't know, Ian Duncan Smith terminology or whatever, and just put like willingness to work. There's a sick Ian Duncan Smith meme. I'm just gonna look it up for you guys now. Sorry if you're American and don't know who Ian Duncan Smith is. Ian Duncan Smith, 50 Shades of Grey. I'm not sure I'm gonna be able to find it. I'm not sure how grey is spelt either. God, such political streaming. I doubt I'm not. Yeah, found it. As she lay there, trembling and powerless to resist, Ian Duncan Smith threw away her wheelchair and declared her fit for work. Just a little jibe at the Conservatives and their cuts to disability allowance. Okay. Yeah, so our aggregate channel registers willingness to work. Every time a worker becomes available, it sends a message to aggregate channel, and aggregate channel is read by the scheduler, the main scheduling threads, effectively, and it just sends out, yeah, I think so, the main scheduling thread is going to read this channel and is going to send out literally just send out any worker that dares to declare that it's free is going to receive a task basically immediately. That's like perfect. That's exactly what we want. So I think that works quite well. Yeah, I'll just for clarity, okay, I'll write free worker sends a message through aggregate channel, which will probably retitle aggregate channel, give it a nicer name. And I don't mean that when I say retitle, I mean actually call it something useful. And yeah, scheduler sends do task to that worker. That idea basically is what I'm thinking. It's what I'm thinking. It's Badly Drawn Boy who has an album called It's What I'm Thinking. I think so. I've always liked that name. I've never listened to the album. About a Boy is, I think, worth checking out. Hour of Bewilderbeast is it's a bit hectic, but people usually prefer it to About a Boy, but About a Boy is just the film, the connection with the film makes it a bit more soulful to me as a soundtrack, just even as the music itself. The context of the film makes you feel it more. So that's it, free worker. Yeah, we have that system in place. And so we have a Go routine called register. That's still a thing, but instead of iterating, well, no, it still iterates over the register channel, but what it does is it forwards to aggregate channel. So this is the point: is register chan is a channel of workers, whereas aggregate chan is a channel of free worker instances. So the idea is that register chan will detect a worker as a new worker once, and then aggregate chan, I'm going to check that that assertion is actually correct, because it says it in the task thing. Iterates over register chan forwards to aggregate chan, so that every worker that's available, which has come through via register chan, goes to aggregate chan because it's free as soon as it's made. Fine, but it can come back to aggregate chan if it's done a task. Like once it finishes a task, it comes back to aggregate chan. And so I'm saying we have a channel per worker, and what that channel does, or a go routine per worker. You know, once the scheduler chooses to send the task to that worker, it spins up a coroutine that manages the interface of that task, and then the worker can reply, and then when it does that, it forwards said worker back onto aggregate chan. It's pretty simple. I think that's simple enough that I could just write it straight down, prototype it straight out. So let me just describe what's going on here. So this is main thread, and then we also have register threads. By thread I mean go routine, really. Like I said, I'm still not certain what the difference is between the two in terms of Go, because I know Go is supposed to make threads lighter somehow. Lighter footprints, lighter to switch between. I'm not sure. It's okay. So yeah, register threads receives from register chan, reads from register chan, and sends the information straight into aggregate chan. But this is the thing, so main thread, free worker goes to aggregate chan, and then scheduler reads from aggregate chan. Well, as in the register thread does this. The main thread, free worker is coming into aggregate chan anyway. This is an assertion, so I'll write that down here. By assertion I mean something we expect is true but we're not implementing. Well, it will be implemented, but it's by something else. So main thread takes things from aggregate chan, which I swear I'm going to rename aggregate chan soon. It's just I haven't thought of a really nice name for it yet. That drops into scheduler, which let's write it down like this. So by this I mean the thread itself. Maybe I should write it as thread. So that particular routine receives from this and forwards straight to aggregate chan. This routine receives from aggregate chan and then forwards to new chan for new chan. Should we make a new channel every time there's a task? / every time a worker is called on a task, start a channel for that, and then close the channel at the end. I think that might be slightly wasteful, but at the same time, reusing channels seems pointless. So yeah, I'm gonna do that. New channel for a task on a worker, which is read from aggregate chan. Right, and that channel runs a new function. So there's going to be a worker management thread, or actually, because it is per task, it's going to be a task management thread, task thread. Okay, and what I'm saying is running task thread, managed by task thread. Right, so new chan is created and that's managed by task thread. Like I said yesterday about Go, it keeps channels and threads completely sort of on the same level, separate. Nothing is subordinate. You can just connect them up. in your code. And so, yeah, I'm saying something manages something that's just a concept that's not reflected directly in the code. It's just that is what it will look like in terms of the program concept, rather than explicitly typing one as subordinate to the other. So that's what I mean. Task thread. This is what task thread does. As soon as we start task thread, we don't need. Do we need a new channel for the worker? I don't think we even need a channel. We need a thread, but I'm not convinced we actually need the channel. The reason we need the thread is because threads are needed in order to wait for that particular task to finish. So the threads awaits the task effectively. That's how we do concurrency, via threads, waiting for stuff to finish. But I don't think we need the channel. Let's try it without the channel. If we do need the channel, I'll put it back in. But basically, calls, so without the channel this would look like this. Calls task thread, by which I mean runs some task function. So task is going to be like a function, but it runs it in a task thread, which I'm going to describe down here. To manage that task, of course, for a task on a worker, and it doesn't need the channel, I don't think. Of course, yeah, aggregate chan tells it which worker to use, but it doesn't need the thread. Sorry, it does need the thread. It doesn't need the channel that I said we could maybe make a channel. The point is, what we're going to do instead, that's the cool bit. Task, for a task on a worker, what we are going to do is task thread basically, or indeed just the task function, or always on a new thread. So as in it's going to be go task. Should we write go task? Yeah, go task. What it does is it's going to be synchronous. Within the thread it's going to be completely sequential or synchronous. The thunder, mate. The thunder. Alright, this is what it does. Step 1. Actually, I don't need to number them. Step 1. Do task RPC sent to worker. I think doing the RPC blocks the thread anyway. I think. I'm not convinced, but somehow we need to await a reply. If it does block the thread, perfect. That's why we have the thread, so that it gets blocked within the thread. The main thread doesn't get blocked. That's important to note. Do task RPC sent to worker, await response from RPC. So in Node I would just write await. I don't know how it works in Go yet, so we'll find out in a sec. So go task, await response from RPC. If success, pass worker back to aggregate chan. I think aggregate chan I'm going to call free worker chan. Else the worker failed. Do nothing in principle. Well, not exactly. As far as the worker is concerned, the worker's forgotten about at this point. So because failure can happen if the worker stops communicating, so we need to forget the worker. It will reappear on register chan, so we don't need to care because we have the register coroutine. I'm going to write go register, and the register coroutine is going to pay attention to if that worker rematerializes. It doesn't actually matter if it does too much. But the thing is, as far as the task itself is concerned, the task still needs to be done. So we have to be careful. Effectively, we need a way of tracking tasks. I said we can use an iterator of n tasks. Range over n tasks. It's kind of hard to use an iterator that has a fixed length and say, okay, I'm going to repeat the previous iteration. So what we should do instead, I think, is do a while loop with a how many tasks are done counter. So let's do that. So yeah, I've rewritten go register. I've also rewritten range over n task. It's going to look a bit different now. I'm going to rewrite it here. It's going to look like this. Tasks done. Integer counter of, or uint if you prefer, it's the counter of finished tasks. Does what it says on the tin. So basically, if success, don't forget the scheduler does not need to deal with the data at all. The data is saved among the workers on those file systems. So the scheduler literally, if there is a success, it passes the worker back, but it also tasks done plus plus. It says, okay, it increments tasks done. Else, it doesn't. So task done is an integer counter of finished task. Okay, we have another problem, which is we need to be able to distribute all the tasks out. We need to be able to distribute all the tasks out in parallel, which means you can't just iterate as such over tasks, because then how do you choose tasks? You'd need the iterator to increase for each task. This doesn't make a lot of sense, so I'm just going to completely delete it. The first sentence I've already implemented, loosely speaking. I'm going to save this because it's starting to get beefy now. Schedule skeleton, yeah. I mean that's what this is all about. Skeletal drafting things. Yeah. What's a good way of iterating over the tasks? So we have the workers locked, but we need the tasks to be constantly being sent out to the right place. Sorry, I said that wrong. We have the places locked. We need to select tasks. We need all of the tasks to be being handled all of the time. So that's something I need to figure out how to do. You know, it says do task RPC send to worker here, but it doesn't say which task. We just need a free task. Should we make a queue of tasks? And iterate, of course, yeah, classic programming is to iterate. You know, if you're doing some sort of search, like a breadth first, a depth first, you would be using something like a queue or a stack in order to store outstanding stuff that needs to be done. And the point is, things can get put back onto the queue or the stack if they failed, or they can get dropped if they've been passed. That isn't exactly how it works in a search. Searches mark things, but the point is, because the situations are slightly different. So in a search, because you're searching, you don't a priori know what all of the nodes are that you have to find. So you have the queue and the stack as a flexible way of logging things that you found by checking like the neighbors of a node. So it's like so it is like I'll do a quick demo. Whoops. Yeah, I'm messing up my own document here quite a bit, sorry. Let me just fix that. Yeah, I want to say else pass, do nothing here. But I'll deal with that later. Yeah, so my example of a graph traversal is like you have a graph. No, it's better to just do this in it to explain what I'm talking about. Directed graph. Google image search. So check this out. We start searching at A. We don't know the full extent of the graph, but our search algorithm will know, it will be able to find all the neighbors of A. That's the thing that you suppose in advance. That's how graphs are stored in memory. Each node is linked to its neighbors. So it can do this, but then when it arrives here, it can do the same thing and it finds C. When it arrives at C, it finds E. When it finds E, when it arrives at E, it finds D and F. And so then it goes to D first, it finds nothing new, and then it goes to F, because it put D and F on the queue, or on the stack. Doesn't matter if you use a queue or a stack at all. Well, it makes a difference in terms of the order of execution. So a stack will get you a depth first search, where you go sort of first as deep as you can go and then backtrack and continue, but a breadth first search will go first up to here, and then it will do one of these, and then it will do the other one in either order. In this graph they give equivalent results, but the point is, instead of going, if this had further nodes, it would go further under depth first search, but breadth first search, if this had further nodes, it would first make sure it's done the first layer of them and then continue on to the next layer. Makes no difference, both have the same give you the same result for a general search, and I think they have similar complexities as well. I'm not sure what the advantages and disadvantages are. Just program whichever one you're more comfortable with, I would say, in general. But okay, those are details. That's the search algorithm. But why is this situation different? I'm still saying use a queue or a stack, even though there is we know in advance what all the nodes are. But the thing is, we have to revisit nodes if they fail to execute, and so they have to be chucked back on the queue or stack. And so you can visualize that as a graph that actually has multiple entries of a single node. Each entry for, one entry for each failure, and then one entry for a success, and then traversing that. So let's do that. Let's do a queue. I mean, I was just saying like, maybe we should do a queue, but then I started explaining how these work, and now at the end of that I'm like, yeah, definitely we should do a queue, or a stack. Do I care if it's a queue or a stack? I really don't, honestly. In Go I could just use a channel if I wanted to. Channels are like queues, quite similar really. Okay, let me just blow my nose. Polls. I should have asked this at the time, by the way, but with this comment, it would be cool to actually know when the distributed class is from. So if it's just a different university, still a similar kind of time frame, like 2018-17, or if it's just a really old course that predates MapReduce. MapReduce, so the MapReduce, I showed the 2004 MIT Distributed Systems course off earlier. Well, 2004 is literally the year the MapReduce paper was published, so. But yeah, I guess I missed my boat on that. I would have to like DM the commenter or something in order to. I still don't really know how Twitch works when it comes to all that stuff. Yeah, let us. we're gonna, oh shit, if we use a task queue. Oh, but no, there's a scheduler, and the scheduler runs synchronously. Sorry, I had a couple of thoughts in my head. I was thinking, do we have to use a lock to make sure that the task queue is not read by the loads of different channels? And the answer is no, we don't, because the scheduler is the only thing that is going to actually be dealing with the task queue, because it individually bundles off individual bits of, it pulls tasks off the task queue and then starts a new thread for that task. So it's quite nice like that. Tasks done is not going to be a counter. Tasks done is going to be... I just somehow with one button I managed to close Visual Studio Code. Like, I do not know what I did. I'm glad I didn't close the fucking streaming app. That would have been a nightmare to deal with. I would have had to resynchronize it and then restart with 2-minute delay. Fucking Visual Studio. What just happened? I want that to be open always, just so I can jump onto it. Cool. Check it out. So tasks done is going to be a list of tasks. Tasks done is quite literally just going to be this. It labels every task, and every task is canonically labeled. What I mean by that is these numbers do actually identify an individual task because of I guess because of the file name. Oh, okay. I see what. So they don't actually. Okay, I mean, it's actually different depending on if it's map phase or reduce phase. Reduce phase is canonically identified by numbers from 0 to n reduce minus 1. Reason being, we saved intermediate files, and so the reduce task corresponds to the file number, the last digit in the file number. On the other hand, map tasks just starts with input files, but the input files are actually in order. It's in a list format, and lists have orders, so input files is actually going to have an order, and therefore we have a canonical order for the map tasks as well. Canonical meaning does not require an arbitrary choice. That is a maths term, which I'm sure some comskis know about. Certainly the ones in fucking Churchill will know about it, because Chinese Gambling Society will have told them about it. Too many mathmos dictating the state of play. Yeah, boy. Okay, so this is what happens then. Literally, do task RPC sent to worker with task pulled off the queue. So let's rename this task queue. The task it's going to be doing is task queue -1, which is notation in Python, among other things, meaning the last thing. Another way of doing that is, of course, the traditional notation, pop. Takes the thing off the end of the list. Probably doesn't exist in Go. None of this stuff exists in Go, but okay. Point is, it gets popped off the queue. Oh yeah, thing about the queue, by the way, is that pop takes something off the queue. This is again from search algorithms. You pop something off the queue, handle it, and when you're done, you either drop it if it's finished, or if it failed, you push it back to the queue. Okay? So that way, if the task failed, it gets put back on the queue and something else will handle it. So the point is, we iterate while queue is not empty, and the main thread is basically going to be working that way. While task queue is not empty, it's going to be pulling out of aggregate chan. Of course, aggregate chan, the free worker channel, is going to have stuff in it even when there are no more tasks left to do. That's fine, we don't care, we just stop anyway. Yeah, we just have to be careful to implement that correctly so that aggregate chan only gets pulled from if there is a task to do. But I think that should be fine, just slightly careful about the implementation. Aggregate chan thread calls task thread for a task on a worker. Scheduler sends do task to that worker. That is subsumed in this sentence. Register thread, register chan, aggregate chan. This is the whole program, I think. I don't think I've left anything out. This is it. So see, it's not actually in code format yet, but I've basically managed to sketch out the entire thing, so I basically know what I'm going to implement now. So I'm going to, gassed as I am, just get on and do that. See if I can implement it. See how quickly I can do that. Yeah, it is, it took me a solid 45 minutes. No, it's actually 1:45 now. It took like an hour and... Yeah, it took about an hour just to sketch how to do this. Which means, it's not trivial. It's not like the previous task. The previous task was actually trivial. The only reason it took so long, well, it took an hour, start to finish, including reading, but nonetheless it took a while because I had to debug it. This is actually, it required design. So it required me to sit down and figure out how to design the thing, and I quite like working that way, so I'll just do it in kind of a pseudocode formats and yeah, go away with that. So channel registering willingness to work. I'm gonna jump away from the Ian Duncan Smith terminology and just call it free workers. Free workers. It's going to have the same format. So the type of free workers is going to be the same type as it's going to be the same type as register chan. So I might just call it free chan, just so it corresponds to register chan. Registers workers currently available to... currently idle is really the word I want. Idle meaning... idle literally means, okay, it's ready to take on a new task. Streaming is checking out, it's working still. Just quickly do the wave test for video sync. Audio sync I can't actually test it out at all, unfortunately. There's just an arbitrary delay that I always edit. This delay here, 250 offset. I set that manually every time I plug the microphone in, because it actually changes the microphones a bit. My hope is that it doesn't desynchronize over time. I think it won't because hardware, but it's not 100% guaranteed, to be honest. So free chan, free worker is on aggregate chan. That's the assertion. That's what I just bundled up there. The register thread pushes stuff from register chan onto free chan. Literally, that's all it does. Go task, do task RPC sent to... Go task should... this function should be something along the lines of... I should write it like this. Do... So just call the function do. Or maybe do task, I don't know. Do task, comma worker. Right. So the point is called task, right, on a worker from aggregate chan for a task on worker from free chan. I would literally, honestly, I would just say like that. Do task RPC send to worker with task, await response. If success, this is now unnecessary because we are literally just, it got pulled off task queue. It's not going to come back to task queue. It's fine. But if you can see, like, if success, pass worker back to aggregate chan, i.e. free chan. Else, worker does not get passed back. Instead, the task gets put back. I think that checks out. So yeah, a new thread for every single task worker pair. Every single attempt at a task. This is a task attempt. Task worker, the pair. Each one of those is going to be a task attempt. Let me just make this all just a bit tidier, you know, more representative of what I was talking about. Calls do task worker thread, or indeed I would just put it that way instead of using the word threads here. That's the task, that's the worker, while task queue is not empty. Shall we just keep editing this until it turns into actual Go code? I could do that. Mum is back. I might actually mute the take like a 5-minute break while she bundles herself back in. No need. Yeah, well, we've made quite a lot of progress now. That's cool. So it's interesting. Like what started off as the aggregate channel hack in order to get something to work has now turned into like an integral part of the program, and that handles conceptually the idea of an idle worker channel. So it's cool that that's happened. Anyway, I am going to take a 5-minute break at this point. Mainly because, well, actually equally because of the distraction outside in the corridor right now, but also because of my dead ass. It's just that numbness when you just sit in this position for hours and hours. I need to figure out how to get away from that. I think what I might do is start crouching on the bed instead, but all is one. I am going to take a 5-minute break. Yeah, be back at 1:58 or so. Just type that into the chat. Just gonna post this for reference. I like the smiley robot. Back at, do you know what, I'm just gonna say 2:00, and then another half an hour to try to implement the code, test the code. I think I can do that in half an hour, and then I'm gonna jump back and try to do the worker failure thing, which I think, given the paradigm we have, is going to be quite quick, because we've already gone through and conceptually made it work. I mean, I've already made provisions for error handling right here. So I think it'll be nice and simple. So I'm gonna that's where we have left it. Okay, back at 2, guys. Cheers. Whoa. Oh my god, my legs, like, ow. Dear lord, this is how I am sitting, like, ridiculous, isn't it? Whoa. Okay. Yeah, I'm going to sit up in this kind of squat position. Whoops. Let me just move the laptop into the right place. And set up my camera and microphone and all that fizzle. Shows if I put the rack up onto the. Hope that doesn't fall off. It might fall off. Yeah, it's a bit dodge, isn't it? It's okay. Yeah, it's raining outside, but not through the window. Thank God. Like, there's no ridiculous level of wind to just push that in. So I can just come up onto the microphone here, move everything over. What? I got a message from someone, or did I? I don't know. What the hell is this? Fucking Windows glitch, it hasn't updated the background. Never mind. Ooh. Okay. Yeah, my camera angle's a bit dodgy now, isn't it? It's like, wait a sec, let me just not waste too much time setting up a fucking camera angle. I wish I had a box that I could put the laptop on. It's kind of low down, and so I'm looking down at the laptop, whereas I could be just looking up like this. Let me just quickly see if I can think of a solution. Hella fast. Just put on a pile of clothes. No, that's going to be very unstable. You know what? There's a box over here. Check this out. I'm going to change the sheets later, but I mean, this is one hella dusty Duplo box. I don't know why I still have it, but I think I can just put the laptop on this. Whoa. This is a highly unstable setup for the laptop, but I think it works fine. Check it out as well, I have plums now, so that's going to be good. Yeah, let's get to work, implement that. I think we should be able to implement and test by the end of today, as in today's session, which ends in half an hour. So let me just put something under the box so it doesn't cave in quite as much like the pyjamas. Pyjamas, come on. Whoa, that was an ordeal, and it's completely tilted the laptop in the wrong direction, so let me just... Well, the laptop's being held up by friction at this point, pretty much, but that's absolutely fine. So let's get back to work. It's enough of a break. There's nothing. I don't think there's anything here that is different from how it's going to be in the final implementation. Right? We define an empty channel. We define a routine that just forwards onto the channel. Main thread is all while task queue is not empty, and then when it is, it terminates. Yeah, I'm absolutely happy to just implement that. What shall I do to... where shall I put this on the screen to be able to see the whole thing? I think here is okay, realistically. I'm pretty sure that's still on the screen for the stream. Okay, let's get to work and just code it all up here. So, for starters, input files for the map task, that should be in the function signature. Map files is what it's called. What else is in the signature? Let's make a note of the signature quite explicitly. I'm going to rewrite the signature here. Wait, where? Oh yeah, after the beginning. So call signature. Of course, thing about this particular call signature is that it's not the actual function call signature. It's just kind of similar because we have new variables. We did basically substitutions. That's what you would call this in maths. We have job name. We have map files, the input files for map. It's only map that actually has those. We have MapReduce is provided as a number. Which has been assigned to n tasks, and we have n other as well. So that's the substitution I was talking about. You know, the substitution is there to abstract away thinking about whether it's map or reduce, because the code will be nice and homogenized. It will work equally well for both. Phase and register chan are the other two. So you know, it's quite an extensive signature. It has 6 different things in it. So first line is just map files. Not going to change it. And I'm going to... I shouldn't be talking and eating at the same time, but I'm just kind of getting hungry. Define all this shit. So first of all, task queue. If we want this to execute vaguely in order, should I maybe randomize the task queue? Randomly sort it so that, you know, it doesn't just pop off the queue. Like if I could have a data structure that pulls randomly out of the queue, that would be ideal. Is there a point in doing that, or is that an optimization I can make later? Because we are pulling workers randomly, that is happening by the design of the channel that registers workers. But I feel like we should also pull tasks randomly. But at the same time, it's probably unnecessary. Instead, I am going to I'm going to make an explicit array of tasks, but I'm going to do it backwards, just so that when we pop it goes in the order 0 to whatever. That's just a design choice that I want to make. It's not actually necessary. We could do the tasks in the opposite order, 0 and down, it doesn't matter. I would like to know the notation for doing a list from 0 to that number though in Go. Like what's the quickest way of doing that? So let's just Google that. This is what I want. Unfortunately, it does appear that I'm going to have to manually construct it because it doesn't seem to be a thing in Go. You know, prototype languages, of course, you can just you can just write it down. In Python, this would be I for I in range n dot that within square brackets dot reverse. That would give you the answer. that you want. So I'm gonna manually construct task queue. So first of all, I'm gonna make an array of integers. That's gonna have length n tasks. So I know how many tasks there are. So this is. No, there's a slight problem. Oh wait, no, there isn't a problem because there cannot be more than n tasks in the list. Because the task gets put back on the list if it's not been done, but it doesn't get duplicated or anything, because it always gets popped and then pushed back. Unless I fuck something up and something gets pushed twice. I'm pretty sure it doesn't, because the thing that got popped, don't forget the scheduler pops everything, and that's running in a single thread. And it also pushes things back, doesn't it? No, actually the scheduler doesn't push. The scheduler should push though. The way I've written it, it doesn't, but yeah, the scheduler should be the only thing that manages the task queue. And the assertion is that every time we pop something, it either gets pushed back or it gets completed, in which case it doesn't. But that does mean that the list is always going to be at most n tasks long, so this line of code is fine. We set aside n tasks, that number of integers. And then we populate it. We have to use a for loop because reasons. Of course, yeah, we can't just use the indices, we have to have them as values as well, just in case things get put back in like the different order. Obviously, if the task gets executed out of order, a random one fails, it's not going to be put back in the original place in the queue it was in the first place. So yeah, this is necessary. Task queue plus equals 1. The linter blew it all out. I don't mean this. I mean this. What is the problem? I is undefined. There, I just defined it. Whether it's int or uint for small numbers makes no difference, uses the same amount of space. Uint is, mathematically speaking, the more reasonable type to associate with an array index, but it's not. It doesn't matter. Uint, I should say, unsigned integer. It goes from 0 to, well, non-negative integers. 0, 1, 2, 3, 4. Natural zero numbers. We would call those in maths. I used to call them natural zero numbers. 0 and the natural numbers. 1, 2, 3, 4. Okay, that's task queue made. And then we define free chan. Make. It's going to be a channel of the same type as a register chan. I'm not sure what type register chan has. String. Okay, string. I wonder if I can just write, like, I can't do that in Go. I can't write type register chan because that would make it clear what this is supposed to be. But that's fine. It's not important. That's what free chan is going to do. I'm not going to assert that manually. It's going to just hopefully work. Main thread. Okay, let's copy. Let's do the main thread code. What is wrong now? Oh, sorry. Again, the assignment operator I forgot to write down. Lightning again, dear lord. Let's pass this in. Sorry, let's paste this in. For. Okay, we are for looping. How do we do a while loop using a for loop? That's something that Go will have to tell you about. It uses notation loss, something silly. It looks like this. That's what a while loop looks like in Go. It's just like a for loop, but we don't define an incrementer variable. We don't do any post-processing, something to do after each iteration of the loop, i.e. I++. We just have the test for whether or not to exit the loop. That's it. So yeah, while task queue is not empty, this is what happens. Sorry. This shouldn't. Forgot to retitle FreeChan. So we call go on do, which is going to be a function I'm going to define later, which is going to handle this bit at the bottom. Ooh. This bit will be handled by the do function. What's up? Go do task worker. Okay, we run that. So we just need to know what task and worker are in order to call that. So yeah, I would love to know if Go has a pop method. Should I just use the channel instead of the queue? I feel like everything in Go is a channel. I may as well make the task queue also a channel. I'm gonna check, honestly, just Stack Overflow, just to see if there is such a thing as pop. Doesn't even seem to be a question on pop, which is really surprising. God, it just seems unnecessarily complicated. Is there really not such a thing as pop? Dear. Yeah. I am switching to channel because it seems to be more idiomatic in Go. Like, on some level, it does seem like Go is being weird for the sake of being weird, but honestly, I mean, I think it is just. So instead of an integer array, we are making a channel of integers, and it's going to be buffered so that it behaves like a list, and it's going to be able to contain n tasks things, because it's never going to need to contain more than that. So that's absolutely fine. And in order to populate task queue with integers, we're going to send them in the correct order this time. Well, this was in the correct order anyway, because I couldn't be bothered to reverse it, but yeah. Task queue, send into task queue I, and then we have FreeChan as well, and then this reads from task queue. Something I really hate about Go is that the arrows, for starters, they're pointing in the wrong direction. Just aesthetic, like I can't visualize arrows that point left as well as I can the ones that point right when it comes to channels, because like data flows in the direction of the arrow. It makes more sense for it to flow left to right to me. And B, you can't use the other direction. You have to use this direction, even though they could easily implement right arrows. I mean, I don't understand that. Honestly, I don't. Pretty sure it doesn't work in the other direction. I tested it myself, but once upon a time, might have tested it wrong or forgotten. I don't know. So FreeChan, we make the string channel. This is no longer a thing. Instead, Ah, shit, yeah, actually, I made a slight conceptual error here, which is that when things get pulled off the stack or the channel or whatever, they have to there has to be another channel for them to be finished in. As in, there has to be a channel that detects that they're finished. Because if there isn't, this will terminate because the channel is empty. Even though channel being empty, all that means is that all the tasks are not waiting to be processed. So either they're in the middle of being processed, or they have already been processed. And so if there's even one that's in the middle of being processed, terminating schedule is going to give the wrong answer because we want all of them to be done. So we need not only a channel to mark what is idle, but we also need a channel to mark what is done. Or in progress, but done is easier to keep track of, in my opinion, instinctively, because we can just, the schedule routine can more or less wait for it to be finished or something. I might have to, we'll see how it goes, but that's the general idea for the time being, that we should be careful not to do the implementation. Yeah, not to fall into that trap that I just described. So I'm gonna have to make a new queue. Idle tasks and done tasks. Done tasks, in principle, is not going to be buffered, because I would like the routine, the send routine, the main thread of the schedule to handle it. And I think that means I'm going to have a select statement that pulls from done tasks, but also, and terminates as soon as it's empty. But at the same time does its own thing, so multiplexing those two things together, that's going to be done via a select statement later on. Just a mental note. That's absolutely fine. That's still working okay. So I've populated idle tasks with tasks. Done tasks is going to be empty and not buffered because it needs to be pulled straight from. So the for statement is going to, this is where the select comes in, okay? So this is what it looks like. Select. Well, select is actually going to be run in a for loop. An infinite loop of select. Case. And it blocks. There's no need for a default case. No need for a default case. We could put like print dot just so it looks like it's doing something, but there's no need for that. I should say in a select statement the default case is the one that runs when none of the others are available to be run. So in this case the ones that can run are going to be these two, tick and boom, something along those lines. It's actually going to be, one is if there is a free worker available, so if we can pull from free chan, then we will do something, and the other one is that we are pulling from done tasks. We're pulling from done tasks. So, okay, let's have a done counter as well. Done counter starts at 0, it's an integer counter. In case, every time we can pull from done tasks, we increment done counter. So it's basically just tracking how many things are coming out of done tasks. Done tasks, every task that gets done, it passes through done tasks, and so the counter gets incremented. Part of me thinks done tasks can actually just be implemented as a counter by itself, but that wouldn't. Off the top of my head, I don't know how to parallelize that. I can't use select to parallelize it, so I'm going to just do it this way, because this way works, I'm pretty sure. And in the case of a free channel being available, Oh shit, I haven't done this. Yeah, of course, if done counter hits end tasks, if every task is done, that's what that means. What's going to happen? Answer, we're finished. If every task is passed through done, we're finished. Break. Because we want to move on to the next bit of code. So we break out of the select statement and for loop. I'm pretty sure break is going to do that. It's going to break out of select. No, sorry, it's going to break out of for. As in, conceptually, break is basically for breaking out of for loops and nothing else. Because everything else, you know, the code is running, it runs the break statement. That means that it jumps out of the if block, it goes all the way to the end of that linear block, which means it gets to here, and then it breaks out of the iterator, and so it gets to here, and then it continues down, and it will print the output here, and whatever, once I've deleted all this garbage that I've written down here. So that's fine. The free chan stuff is this. The thing that got pulled out of free chan is the worker. So hopefully this will make a nice dummy variable for me called worker. You know, task is pulled out of idle tasks, and then both of them are called on go do task worker. Okay, that is it. That is the main thread. I've implemented everything I said I would. Let me just delete the garbage. If you look at the let me just set the camera. Camera's okay. Camera is not bad, mate. Yeah, everything I said I would implement in the main thread. Task queue not empty. You know, for every free channel. This is the loop. So instead of task queue not empty, we have pulling out of done tasks. Counter is incremented, and if it hits end tasks, we break. So that's simulating non-empty. It's as if when we have this for loop, we always do this test. But oh, I get it. That's a good point. I can yeah, instead of using a select statement here, I can do a case this, but default case continues, so it doesn't block. It's like a non-blocking wait for stuff to come out of, wait for workers to come out of free chan, new workers. So a non-blocking way of waiting for new workers, where default case is just run the loop again. But then every iteration of running the loop runs this test with the done counter. So the only trouble with that is you need a way for done counter to get incremented. And having a different thread increment done counter is, I think, not thread safe. I think that's something you're not supposed to do because it could lead to problems. I'm not sure if it will because it's just an atomic edit of a number, but I think that's why you want to use channels, unless you can get the scheduler to explicitly do the increments itself, but you can't because that's the point of having the go routine in the first place. Everything blocks. There are no await statements running in threads within a particular function. Every sequential execution happens within one function, right? And so therefore this is an asynchronous call. It gets called and then the function continues and forgets about it. There is no feedback. The way feedback is done is via channels. Therefore I deduce that a channel is necessary in order to detect things that are done, even if I am just tracking how many things come through here and incrementing another counter. So even though I need both done tasks and done counter, I think that's why it's necessary, that explanation I just gave. I think, not sure, but seems reasonable. All right, let's get on with it. I mean, I think the rest of it is just copy and paste. these two things. So let's copy and paste them. Okay, a couple of things. First of all, so these need to be defined as functions. So let's do that. Oh yeah, and they should be defined outside the main function body. So function number one is going to be the register function. This is a routine that takes no arguments and returns no arguments. It's the empty function in maths. But of course, because this is not functional programming, the empty function actually does something. And this is what it does. This is going to be run as a coroutine. It's going to be an infinite loop that forwards everything from register chan into free chan. I think this is the way you write that. Ah, shit. Register chan is not, oops, is not defined, but I can just point a reference to register chan. I'm pretty sure if you pass channels, what you're doing is passing pointers to channels. You don't, it would be crazy if Go duplicated the channel every time you pass it into a function. So I can just write, okay, so this actually does have to take register chan and free chan as an argument. It's just a forwarding. It's a forwarding routine. In fact, let me just Google. I'm sure this is a standard Go idiom. I'm just going to check it out quickly. I think this is what I'm looking for. Forward Blixt. No idea. Sounds Dutch. Go on the lightning still. Forward the value from one channel to another without blocking and without wrapping one select case inside another. Ooh boy. I'm starting to get scared. I should probably not be sitting so close to the fucking... If I get hit by lightning. I don't know. Let's say we close the window. That'll make me feel a bit safer, even if it's a bit less atmospheric. This is a bunch of stuff. I'm just going to do it the way I think it should be done. I'm going to call this function forward. It infinitely loops, sending stuff from register chan into free chan. Literally. Laptop is getting quite hot, isn't it? Well, indeed it is. Usually when the window's open I can't actually hear the fan or anything, but... Forwards... Oh yeah, what types are we forwarding? Well, they have to be the same type, so I'm just going to do a chan int. A forward from A. This gets forwarded to that. So I'm going to go B arrowed to by A. Hopefully that will just do what I want it to do. The other function we need is do task worker. Task, which is of course an integer that marks the task, and worker, which is, what type do workers have again? Are they also, oh shit, yeah, the strings, aren't they? My bad, sorry, yeah, workers are the type. Conceptually speaking, worker is the type that is going into both of the channels, the register chan and the free chan, which we're going to be forwarding using this forward function. And workers from free chan are what go into do. So yeah. This is also running concurrently in a Go routine, so no need to return anything. Returns wouldn't be detected, I don't think. I think anytime you run something as a Go routine, it's not supposed to return anything because nothing is listening for the return value, because the thing that called it just continues without waiting for anything. It just calls it and continues. Okay, check it out. What we need to do is this. First of all, the RPC needs to be sent out. That means dealing with a lot of boilerplate. Oh, whoops, I pasted this in 2 different places, sorry. What I will do, just before I type out the do code, I'm going to put the forward code in the main function, which is pretty simple because it literally just requires typing go forward register chan into free chan. That's all that I ever wanted it to do. Again, using go in order for that to just be running in a thread in the background the whole time, so this can continue with its work. And do task worker is what now needs to be implemented. Let me just comment this just to make it look a bit nicer. It's looking really terrible. So this literally, what's this? Undefined worker. Cannot use a type chan string as type string. Yeah. So this is not possible to do syntax error. You just have to go. I think this would work. In fact, this would work. Yeah, that's what a forward looks like in Go, apparently. And it doesn't even have symmetric spaces or anything because of the linter. Never mind. Okay, let's deal with this stuff. So we need to learn how to do an RPC. So I'm just going to quickly flick through it here and get the notation out. Right, you need to use call from MapReduce common RPC. So it's package MapReduce, which means that I should be able to I think I should just be able to do this. You know, the exported call from MapReduce. The actual syntax helper is not telling me anything, but never mind. First argument is the worker's address as read from register chan. So the worker's address, we passed it in from free chan, is literally just worker, that string. Right, second argument should be just the string worker do task. We said the last argument is nil, but what's the third argument? should be the do task args structure. Okay. Yeah, see what you mean. I think this might not be necessary to get it to work. Sorry, args needs to be defined. No, it seems the type is available, but call has to actually be prefaced by the package name for some reason. This is undefined MapReduce. How do I call a function from a different file? It's definitely possible to do that. Let me just find out how. What the hell is that? Is so much lightning. So it's calling doMap and doReduce. Where has it imported them from though? Obviously doMap and doReduce, they come from a different file. And they're just being called as is. Okay, so I think I should be doing this. That seems to work. Okay, so I need to use the type to define some task args. What are they? Job name, file, phase, task number, num other phase. Dear Lord, I have to. I can't even. I need to pass that, all that shit into the. It would be nice if I could use a closure to do this, but I don't know how to use closures. So a closure, the idea is you can define a function that has inbuilt variable values from a different context, which would be nice because job name, most of this other shit just comes from that. But instead, because I don't really know how to do that, I'm just going to make an args, task args, requirement in the signature, and that's going to have type do task args, which I don't really want to be copied, so I'm going to star it. Hopefully that works. Right, and I think that works. So I just need to go back and why did it say worker is undefined here? Because that notation doesn't check out. I'm going to fill that in later. This is at least syntactically correct. Okay, fine. Pass the pointer in. My bad. The pointer. But yeah, the worker is I need case to define a variable. This is definitely possible to do that. Otherwise, things would be stupid. Like, it would be properly terrible. See, it says here C arrow X. So why is it not letting me do that? I just said like worker arrow free chan in my select statement. Why does it work here and not there? I'm just alt tabbing and looking incredulously. No idea. I need select to be quoted. Apparently you have to do that. But then why? Oh, no, I understand. It's because the this works as an assignment, but not as a declaration of the variable. So here I have assigned to worker, but this doesn't automatically declare worker. Do I want it declared or do I want it block scoped? I think I want it to assign it here so that when the case drops, worker is there, but it doesn't otherwise. Check it out, no problem so far. Unreachable code, of course, meaning there's a do function here that is not being called by. Oh wait, what? 55.2 is unreachable. How is that unreachable? It is not. There's a break statement in the correct place. Maybe it just thinks it's unreachable. Never mind. Okay, let's push on and do the call. I want to know how call works again, so I'm just going to jump back and check. Can I just click that to find out? Go to definition. Very nice. Visual Studio Code. IDE. It returns, oh okay, no, it has return values. Returns true if the server responded, and false if no reply. Oh, and nil is where the reply gets saved to. Is that correct? What's the call signature again? SRV RPC name args reply. Okay, so reply gets saved to reply, but the reply is valid or not depending on if call returned true. Okay, so call returns true or false depending on success and saves its output value to a memory address that is passed in to reply. That's what call does. So all I need is a Boolean success, which takes the value of what call is, sends the task, awaits the response, and if success. Yeah, let's make the code a bit more fucked up. Single line this shit. If that returns success, worker gets passed back to free channel. Because yeah, if the call returns a success, I'm pretty sure that the worker is going to be free at that point. That makes sense. It's fine. So free chan now gets sent worker, and the else statement is just that idle tasks gets the task pushed back onto it. Task and worker are just strings and integers. We don't need to use pointers or anything. They just identify them. So we would use a pointer if there's more structure to them, if it's like a whole thing, the object itself, rather than just an ID. IDs can be copied easily. They're just like strings and integers. But if it's a whole task, you wouldn't want to copy it. Just to pass it to something to do, like to call a function on it, you would want the thing to stay the same, and that's why you would use a pointer. That's why you would pass a pointer to the function rather than just copying the ID over. What the hell? Free chan is undefined. Oh my god, I have to pass the channel. Again, the same problem with closures. That everything. But I'm not gonna bother with closures, honestly. I'm just gonna do the call signature thing. Free chan is a chan of strings. and idle tasks is a chan of integers, which now need to be passed in here. Free chan idle tasks. So again, it's saying that the code is unreachable. But at the same time, I'm pretty sure, unless this break statement does not do what I want it to do, which I believe it does, we will find out imminently by running a test. But that's it, like I've implemented the code as I said I wanted it implemented. How long is the code? Just curious. I want to hide the panel. Oh yeah, I can control prime to get rid of it. Close panel and then control prime to get it back up. Basically this code here, and it has these helper functions associated to it. These functions, I could define them within schedule, but best not, because the logic is that these two functions are they are run in separate threads, and so I wouldn't want to put them in this, which logically corresponds to a single thread. Oh, but I guess it doesn't, because I'm making these channels within the scope of schedule, which, I definitely should not be doing that. Yeah, all this structure should be outside of schedule. And maybe then I don't actually have to pass things into functions. I'm going to experiment with that. So let's do that. So we're gonna define some variables outside of all of the functions. Just all of the channels that we're going to be using, those are going to be defined here. Let me just see if that gives me any errors. Non-declaration statement outside function body. These are declaration statements though. Yeah, but you're not allowed to use this assignment operator. You have to write. Okay, yeah, you have to write var free chan string equals make chan string. I think that works. Yes, it does. Just a bunch of redundant notation. Oh wait, no. Is it possible to do this? Yes, it is. Oh, problem, end tasks. That has to be passed into schedule. The entry point of that is schedule. So, as far as idle tasks is concerned, that channel has to be built by schedule. Register chan happens outside it, but the forwarding is set up within schedule, so all of these channels are safe to be started within schedule. It's just the thing that I said about passing into the function. As much as I don't want to subordinate this into the function, I think I'm going to have to do that. So undo everything. Blam. We're back to square. Gonna just clean up the code slightly to my satisfaction. So this is handling the worker channels, and this is handling the task channels. Again, I think this works, so let's just test it. Super fast testing. And then I'll call it a day if it works. Hope it works, man. it's not on verbose, so we should just be able to test it. And like I said, now that I've set up Visual Studio Code a bit better, I can test it from the terminal. Although I have to do this, don't forget. Okay, our problem is the following. What is the problem, sorry? What? Talking about loads of input parameters. Oh yeah, wait, ooh, shit, I forgot to implement the task arguments thing. Do you see task? Yeah, see the, oh god, yeah. Just because the code is syntactically valid, that doesn't mean I actually implemented it at all. So let's implement it now. And I'm gonna match the signature, so I'm gonna write job name, file, shit. Yeah, this is the special case. Sorry, okay. Let's make it completely explicit. So file is not going to be set. It'll be set, but not immediately. Phase, job phase. Job phase is what it looks like in the signature, right? Yeah, but it's not spelled like, yeah, no, that is it. And job name should be a lowercase j as well, unless they've messed things up. Yep, camel case is on point. Task number, num other phase. Okay, so I specified those correctly, num other phase and task number. Task number is task. As in, that's how I identified it. It's the identifier of the task, and num under other phases and other from the initial signature. Just got to be careful here. So the file name, we said. Oh, do these have to be commas? I suppose. Even that has to be a comma. Type job what? Phase. Oh, phase has type job phase. But this has name phase. This has name phase and type job phase. I'm literally just linking the functions up now. Nothing too mentally taxing in what I'm doing. Just got to be careful to get the names assigned to the correct identifiers and whatever. The only one that requires a bit more care is file. So file is only assigned in the case that we're working with map. Phase has type job phase. Oh, come on. You made this a lot more complicated than it needed to be, MIT. Yeah, it says here type job phase string. So let's go to definition to find out how that's supposed to be used. Does not say anything. These are the consts. So map phase, job phase is map phase, and reduce phase. Yep, so why all this complication, I do not know. It's like some sort of artificial type safety that's completely unnecessary. Could just throw an error if phase is not the map phase or reduce phase. If it's some arbitrary string, you could just like handle that rather than, I guess, static analysis. You know, being able to tell without running the program if it's correct or not. That can be done by possibly by having types like this. I'm not sure it actually works though. See, if I do like this, I mean, that's not gonna give a problem, is it? Indeed, it's not. Well, it doesn't give an error related to this at least. Task args dot file is going to equal file map files specified by the task number. This is what we said about task being canonical because it refers to the file number. I'm using task here to pick out the correct file as the input. Done. Okay, cool. That's terminal. Shit. Can I wonder if I can just by like... No, that doesn't work. I wanted to see if I could just copy from the console. I have to highlight it, but it's fine. No, it didn't work. Fine, in that case I will just do that. Haha. I mean, I have now assigned the task args correctly. Passed in the memory address. The two correct channels. So where is the failure happening? It's telling me I am using an address that's not compatible. So I'm going to do a bit of print debugging. I guess I could use the debug thing that we were talking about yesterday, but I've decided not to. Just for simplicity. This FMT print learn is easy enough, honestly, for me to just do. What am I going to print? A bit of debugging information, so I'm going to print the task number and the worker. Okay. I would love it if I could have a keyboard shortcut that auto inputs FMT print learn for debugging purposes. It's probably possible to set that up in Visual Studio Code, but for the time being I will allow it. Okay, so again, call failed. It should be that it should only print one instance of this stuff, but actually it seems that it's not even to me it seems that there's an error here that has nothing to do with my own code, that it's actually just messed up for some reason. So am I going to have to debug MIT's own code here again? I'm just sizing up the prospect of having to do that at the moment. But it gives no other information. Alright, first step to seeing if we can get any more information is to set debug to true here, which is the verbose version, which is going to print loads of shits in principle, but it's not going to print anything. This is the thing, because it's broken from the get-go. I think it's something that MIT fucked up. Or maybe it's just something that doesn't run on Windows. the RPC protocol. God, it's annoying having to deal with errors like that that are, you know, manifestly not your fault. So yeah, maybe I should just leave it there for now. We've done the code. It took a long time to conceptualize, to implement, and sadly I do not get the privilege of testing it because there's some sort of error in the rest of the code. Anyway, I am for sure not going outside, so I'm just gonna cancel on my friend because today is not a day to be going outside. The weather's just been so dodge lately anyway. This was always a possibility. Instead, I am going to... Shall we jump on and try to debug this? And then get lunch? I'm chilling after this, by the way. The next stream's going to be tomorrow. There's no way I'm getting everything done in 3 days, but 4 days looks on. So I'm going to try for 4 days. No problems. Just keep at it. 4 days, as in from the start of streaming, from when I began the whole project to the end of MapReduce, which I think is still good. Shame I couldn't do it in 3 days, but this bug here. Okay, I'm gonna debug, get my hands dirty. I will try to speak my way through what I'm doing, but in principle the stream from this point onwards is going to be inferior to the stream so far today. I think it was a good stream today. I'm happy with how it's gone. But yeah, I am gonna try to debug this.